Hello everybody, I am Manideepa. In this video, I shall discuss about semiconductor diode. Semiconductor diode is at the very center of much of today's electronic industry. In fact, semiconductor technology is present in almost every area of modern day technology. The learning objective of this topic are understand the diode operation and solve circuit using the ideal diode model. Now, what are the basic concept of a diode? Generally, silicon and germanium are used to make diodes. They are the two most common single element. A compound is also there, that is gallium arsenide. This is used to make LED, light emitting diode, because of its direct band gap. Okay, now silicon and germanium are both group 4 element, that is they have 4 electrons in their outer shell. Now all the 4 electrons are used by the semiconductor atom in forming bonds with its neighboring atom, leaving a low number of electrons for conduction. When a dopant from group 3 or 5 are added to silicon or germanium, it changes the properties of the material, so we are able to make the P and N type materials that become the diode. Okay, so now N type material. So in the N-type semiconductor, electrons are the majority carrier. So N-type semiconductor are created by doping an intrinsic semiconductor with donor impurities. Okay, so here the silicon is used. Silicon have 4 electrons in the outer shell. Now, if a impurity, if a pentagon impurity like phosphorus, arsenic, antimony are added, then this impurity have 5 electron in the outer shell. Okay, so this electron can be used for conduction, or these electron can move around the material freely. So this excess there is an excess of electrons or negatively charged carrier, so these create a N-type material. Okay, so now P-type material. P-type materials, so in the P-type semiconductor, holes are the majority carrier. So similarly here we use a impurity of group 3 element. So group 3 we know that group 3 element have 3 valence electrons, so there is an electron missing, so these create a hole or a positive charge that can move around in the material. So in this way, P type or hole, or there is an excess of hole or positively charged carrier. So in this way, P type material can be created. So the group 3 dopants are aluminium, boron, gallium, etc. Okay. So now most important thing is the p-n junction. So the p region has an excess of hole, while the n region has an excess of electron. When the two areas meet, the electrons fill the holes and there are no free electron or hole. This means that there are no available charge carriers in this region. So this region is known as the depletion region, and the junction where the p-type and n-type material meets is known as the metallurgical junction. Okay, so the depletion region includes the net positively and negatively charged region, and this region does not have any free carrier. Now Na and Nd represent the amount of negative and positive doping in number of carrier per centimeter cubed. So these occurred when no external sources is connected to the p-n junction or steady state condition. So diffusion and drift balance each other for both holes and electrons. So when an external voltage is applied to the PN junction, then biasing is occurred. So biasing, there are two type of biasing. One is the forward bias and another is the reverse bias. So when applied, positive part of the applied voltage is connected to the p-type material, then forward bias is occurred. So in forward bias, the depression region shrinks slightly in width. With this shrinking, the energy required for charge carriers to cross the depletion region decreases exponentially. Therefore, as the applied voltage increases, current starts to flow across the junction. The barrier potential of the diode is the voltage at which appreciable current starts to flow through the diode. Okay. Similarly, when the negative part of the applied voltage or the applied voltage is connected to the p-type material, then reverse bias is occurred. So under reverse bias, the depression region widens. This causes the electric field produced by the ions to cancel out the applied reverse bias voltage, and a small leakage current, that is saturation current, flows under reverse bias condition. Okay, so the this is the current voltage characteristics. So a semiconductor diode's behavior in circuit is given by the current by its current voltage characteristics. The shape of the curve is determined by the transport of charge carriers through the depletion region. So when the diode is forward biased, that is anode positive with respect to the cathode, a positive current passes through the diode and operates in the top right quadrant of the graph. Okay. Now when the forward voltage exceeds the diode to PN junction internal barrier voltage, that is 0.7 for silicon, avalanche occurs and the forward current increases rapidly as it is shown here. Okay, so for a very small increase in the voltage, so for small increase in voltage, there is a very high current. Likewise, when the diode is reverse biased, that is cathode positive with respect to the anode, the diode blocks current except for an extremely small leakage current and operates in the lower left quadrant. Okay, so the diode continues to block current flow through it until the reverse voltage across the diode become greater than its breakdown voltage. Okay, so it results a sudden increase in the reverse current, which produces a straight line downward curve as the voltage loses control. Okay, so this reference breakdown voltage point is used to good effect with Zener diode. Okay, so this is the properties of the diode. Now ideal diode model. So this is the symbol of a diode. The diode is designed to allow current to flow in only one direction ideally, and perfect diode would be a perfect conductor in one direction, that is forward bias, and the perfect insulator in other direction, that is reverse bias. Okay, so there is an example. So assume the diode in the circuit below is ideal. But this is the ideal diode. Determine the value of ID when VA is equal to 5 volt and VA equal to minus 5 volt. So what will be the value of the ID? Now with VA greater than 0, the diode is in forward bias and is acting like a perfect conductor. So ID will be equal to VA by RS, that is equal to 100 milliampere. Now with VA less than 0, the diode is in reverse bias condition and this acting like a perfect insulator. That is acting like a perfect insulator. Therefore, there is no current can flow through the diode, so ID will be equal to 0. So this is the all about diode. Okay, thank you.